Hi, welcome to Physics on Table channel. Today I'm going to start mathematical physics for IIT Jam Physics. Okay, so the first chapter I'm going to start today is matrices and determinants. So in this portion we are going to study some basic properties of matrices and determinants and going to solve some problems. There are various type of matrices. We are going to learn their properties and also some standard matrices examples. Okay, the main important thing over here is eigenvalue and eigenvector. Okay, so let's start. So we are going to start with eigenvalue. So what is it? Okay, I like to cite examples and to teach you. I hope you will be comfortable in it. If you have some problem, kindly comment it below. Okay, okay, so let's go to the next page. Yeah, may change the background to suppose this color. Okay, and pen orange. Okay, okay. So we're going to study what is eigenvalue. Suppose we have any matrix. Suppose we have this matrix A, B, C, D. Okay, we have this matrix. We have another matrix X, Y. We have any value lambda and XY. You get my point? You know, I hope you know, as you have come across class 11 and 12, you have studied matrix. It's the representation of an equation. Okay, so it is ax plus by equals to lambda x, cx plus dy equals to lambda y, and we have written this in matrix form. Okay, I know you people know about this. Now what is this eigenvalue? What is this eigenvalue? This lambda is known as eigenvalue. So let's go to the next page and learn this. You have seen that I have written this thing, this thing as this. Okay, we're going to assign this as A. That is, matrix A is A, B, C, D. Okay. Okay, let me rub this. Okay, so let me assign this as A. I write this entire thing as capital X. Okay, capital X. This is small x, this is small x, capital X. Okay, I write this lambda and this whole matrix as capital X. Okay, this is an equation which is nothing but representing this one, this matrix equation. Okay, so let's go to the next page. We can write ax is equal to lambda x, right? Okay, so this matrix is actually known as coefficient matrix. I have remembered in my undergraduation mathematics oral. Mathematics was my general paper. Madam asked me what this matrix known as. Yeah, she told me this is coefficient matrix. I told a different answer, but that was also correct. I can't recall what I have told. This is actually known as coefficient matrix. Okay, so this x is known as eigenvector. And this, obviously this x and this, both the x are same, so both are known as eigenvector. And this lambda value, which is most important, is known as eigen value, eigen value. Okay, so this is the basic concept. So we can say ax is equal to lambda x, where x is known as eigen vector, lambda is known as eigen value. Okay, this is the basic definition of eigenvector and eigenvalue. Next move to the next page. Okay, let me change the background. It's fun for all of us. YOLO. Okay, dirty fellow ऐसा नहीं बोलते. तो चलो तो हम करते हैं ax is equal to lambda x. You got this equation? Okay. I think you have remembered what is known as an identity matrix. It is 1 0 1 1 0. Actually it's 1 0 0 1, right? So if we multiply in any portion, in any side I, it gives the same thing, correct? So if we multiply I in this side, so obviously the meaning doesn't change. Are you getting my point, what I am saying? Ax is equal to lambda x. Actually what in matrix form, if in general case if we multiply 1 in this side, the thing remains same. It's similar in matrix case. If we multiply I, that is identity matrix, in any side, this becomes the same. What is multiplication with 1 in general case is multiplication with identity matrix in this case. Obviously the dimension should be same. I have assumed here that x is 2-dimensional. If it is 3-dimensional, the identity matrix should be 3-dimensional, and so on. Okay, so let me remove this. Yeah, so okay, we get this equation. So what can we do? We can take this side, this one to this side, and it will become a minus lambda I x is equal to 0. Okay, let's go to the next page. In the previous page we got a minus lambda I is equal to 0, and x can't be 0, it's the eigenvector, so we have taken this. Okay, see, we have got this, x can't be 0, so this should be 0, and we have written that equation. So if we take the mod of this, okay, like this, a minus lambda I is equal to 0, this equation, this equation is known as characteristic equation. Characteristic equation. Okay, and yeah, this is known as characteristic equation. And if we just write a minus lambda I, this one, this will give you a polynomial equation. You will see in later stage. This is known as characteristic स्पेलिंग रॉन्ग हुआ ना शायद, सॉरी, CHARACTRIS ना, ठीक ही है, TIC, ओके, characteristic polynomial. Okay, so this is the basic definition of eigenvalue and eigenvector. I hope the concept is clear to you. Okay, so I end the video over here. So let me summarize what we have studied in this video. We have studied from the big eigenvalue and eigenvectors. We have taken a matrix and also xy matrix, and here we have written the equation. We have taken this matrix as A, multiplied with x, and capital X is assigned as the matrix x and y, which is a column matrix. Okay, and we then have studied what is eigenvalue and eigenvector. This lambda value, when A and x is multiplied, we get the lambda, and this lambda value is known as eigenvalue, and the x values are known as eigenvector. Okay, so yeah, as I have told, next we have just multiplied identity matrix in any side, and as I have told, it signifies 1. So just with some algebra we got this, yeah. And from here it's a minus lambda I is equal to 0, and if we take mod of a minus lambda I is equal to 0, this equation is known as characteristic equation, and this one is known as characteristic polynomial. Okay, so let me end this video. I hope the basic definition of eigenvector and eigenvalue is clear to you. If you people have any problem regarding this, you may message me in the comment. Okay, thank you. Thanks for watching the video.